Hello everyone, welcome to the second chapter of our series of video about how to go from data to big data analytics. Today we'll talk about MPI. The last chapter was about trades. We kind of discussed how to do distributed computing on your own computer. Today we will explain how to do the same thing on a network of computer using MPI. So let's get started by defining what's MPI actually. So MPI is an acronym for Message Passing Interface. It is a standard for parallel and distributed computing. It is kind of a communication protocol that helps to make computation on different computers within the network easier for us developers. So it had been here for a while. I think the first specification was written in 1994. And today we have the version 3.1. We have two different modules when we're working with MPI. We have the software itself, the written code, I think it's in C++, that you have to install on your computer. And depending on the programming language that you are using, you will have to install maybe under the package on your computer. Like for Python, you have to install MPI for Py. And in order to kind of have access to a simple API for MPI in Python, in your Python code. MPI have a lot of functions and have a lot of ways to communicate between computers. We have point-to-point communication, collective communication, and one-side communication. And in this video, we'll just talk about point-to-point communication and collective communication. We'll also give some example on how it actually works. What about what is exactly a rank, worker, slave, and much more. So let's get started by showing how to install MPI on your own computer. Here I have Linux on my computer, so it's kind of really easy to install MPI on your computer with Linux. You just have to type sudo apt install open MPI bin, then open MPI command. There's a lot of packages you have to install. I'll just I have a blog post. I will write a blog post on ulife.ai. I will put the link in the description, so you have everything, code, commands, and everything you need. I will just add the second section for Windows in the blog post because I don't have Windows on my computer to show it to you. So if you are using Windows or Mac OS, you just have to visit the post in the description and see the process for your operating system. So here we have open MPI command. Okay, open MPI doc also. Then leave open an MPI dev. Okay, I think most of those packages are installed on my computer, so it will not. Yeah, I would not install it anymore. So when you will do it for the first time, it will install MPI on your computer, and after that, you will type this MPI run. You can just type it with whatever. If you get something like not an error or no comment, it means it had been completely installed on your computer. And then you can use this command to run programs with MPI. So let's get started by using the hello world. I'll just show it to you in the VS Code. This is the structure of an MPI program. It's not really different from a common Python program. And to start, let me just open a terminal so I can show you everything. I think there's a problem when you install it with Conda. So I will just deactivate Conda and install it and work on my local Python version. So Conda deactivate. Okay, so I have everything good here. This I have to install. If you need to use MPI in Python, you have to install this package called MPI for Py, and it's quite easy to install. MPI for Py. So I have it on my computer, so I don't need to install it anymore. And to run this hello world program, you just need to type MPI run. You define the number of worker by giving a parameter n number of worker. I just say 5. I think I have a 5 process on my computer. It will just simulate an environment where there's 5 processes sending data to each other by message passing. But in a network, actually what's done is actually the same thing that's done in a network. So when I do this, I just type Python, I execute my file normally, .py. you will see each worker, like worker 1 saying, okay, hello from me, hello from this process. So each process is saying hello, 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 hello. So let's just explain each line here. This COM is kind of the global module from MPI. It is also the default communicator. The worker is actually you. It's a process, it's a computer. In MPI, there is a number attributed to each computer. The first computer will have the rank 0, the second will have the rank 1, and so on, like a normal array. And the size is actually the number of computers you have on your network, or the number of processes. In our case, we have 5 processes. So you can see worker 1 of 5. You can see it here, hello world from worker 1 of 5, hello world from worker 2 of 5, and so on. So this is how we write a simple program of MPI and use 5 processes to compute something simple. So after presenting MPI, let's go to the next part. The installation, I think we did it, is complete. But let's go in MPI itself by talking about the first topic, that's actually point-to-point communication. So in a normal network, you have many nodes. Each node can just send a message to wherever. So the point-to-point communication is actually this configuration. You have one node that can send message to any other node. That can be any kind of message. There's no limit to those messages. But actually, in the Python API, you have 2 different kind of way of writing function. When you write it with the capital letter at the beginning, and you can also write it with the small letter at the beginning. So it depends. If you want to send a common Python data, you have to use a capital letter. And when you want to write, you send any kind of data, like objects or dictionary or more complex data, NumPy data, you have to use the small letter one. So let's get an example of point-to-point communication that I will just show you in the code. Let's first explain the concept, and I will show one code. So here, for example, we have many computers. We have 1, 2, 3, 4, 5 computers. I have 5 processes, so it's normal that I choose 5 computers. Each computer have a rank. Like this one is rank 0 until rank 5. Let's say we have a simple computation. This can be something more complex than just adding, like, multiplying number by 2. We just take this process to show you how to pass message from one computer to another using point-to-point communication. But you can do much more stuff with it, like I don't know, like a complete pipeline if you want, or whatever. Just keep in mind that when you are able to send data or array or objects from one computer to another, you can do whatever you want from a network of computers. So in our case here, we defined an architecture. We have this rank 0 that have the number 2. And all we want to do is, like, for each rank, we multiply the number that he received from the last worker by 2. So for example, this rank will have 2. The rank 1 will take this 1 and multiply it by 2. The rank 2 will take this 4 and multiply it by 2, and so forth. And we'll get to the power of 6, I think. Let me show you the code of this point-to-point communication so you can see how you can pass message to multiple computer and compute something on this data that you receive from them and pass it to the next. So this is the code of what we are explaining here with this 2, 3, 4 until 64. We have this initial number, that's actually 2. The first worker with rank 0 sent the 2, the initial number, that's 2. We can just say 2 here. It's not really important to keep it in a variable. The next worker will be the next condition will be about this last worker, because when we reach this worker, we are not supposed to send something to another computer or another process, because there's no other process in the network. So we just print it. What we receive, we just print it. We have to multiply it by 2 before printing, so we are doing it here. The number that we are receiving, this function helps to receive data. You can just specify the source. As we have here worker, our rank will be worker, and the rank of the computer before us will be rank -1. So 4 minus 1, that will be 3. So we receive this data from 3, and we print it by multiplying by 2. This is an exponentiation. Let me just, sorry. By multiplying it by 2. But otherwise, if we have those intermediate computers, what we do is like we get from this and we send it to this. So if you are rank 1, you get it from rank 1 minus 1, and you send it to rank 1 rank plus 1. So that's actually what we're doing here. We receive message from worker rank from the source worker minus 1, and we send it to the destination worker plus 1. And let's execute it to see the result of our program. Oh, I think I made a mistake on the slides. Actually, this is not 16, it's 8. So we are supposed to have 32 here. That's the reason why we are getting 32 here. Yes, so, yeah. Anyway, it's the same process. What we receive from the last worker, we send it to the next worker. So when you see this basic code, you can just extend it to do whatever you want from the MPI API. So with that said, we have to go to the next point. That's actually collective communication. I think we have a good example about point-to-point communication, and you can use this to do a lot more interesting stuff. Maybe, yeah, like a complete pipeline, as I was saying before. So concerning the next step, what we have here is collective communication. And in collective communication, we have some concept that you have to define first, like the concept of master and slave. In a collective communication, we have one person that's actually managing the whole communication between nodes. It can be the first node, for example, that actually maybe say, okay, I will send this to this one, I will send this to this one, or I will receive data from all those nodes. And the slave are just the node that are actually receiving the data or receiving the instruction about maybe sending the data to them or something like that. So this is a really important concept that you have to understand. Let's go deep into the different operations that we have in the collective communication by starting with the scatter operation. This scatter operation is actually really simple. This master rank worker here have some data like equally distributed that it can kind of distribute equally. Okay, so what he does is like he get this 4 things. If you have 4 workers, like I have 5 process here, this will be one will be the master and the 4 other will be the slaves. This master will actually just dispatch the data that he have to all the nodes. So each node will get one part of the data, like one chunk of the data. So let's show that in the code actually. So this is the code for scattering actually. What is done here is pretty simple. We have the same com size and worker that we had before in the last examples. We have this worker that's actually this master that's actually the worker 0 with rank 0. It has the data. I mean, we just generate the data dynamically here. We will have data for 1, data for 2. It's a dictionary, an array of dictionaries. And in this array, what we want from this is actually to just dispatch this data to all the 4 nodes that we have. So this function scatter would do it for you. So if you have a really large array that you want to distribute to different computers so they can compute and maybe send you the result, I will show you how to get a result with another operation, with the reduce operation. You can use this scatter operation. It will just help you to split the data and share it between all the nodes. Like for example here, I will just show you what each node is getting and what the master actually have. Let's just execute it. I think it's Python 5.py. Yes. And if you see here, these have data 1, data 2, data 3, data 4 for everyone. Okay. And he sent the data to each node here. You will get that node 1 get this first part, node 2 get the second part, node 4, node 3, and so on and so forth. So this will help you to distribute your data easily between nodes or process. Okay, let's get to the next operation for collective communication. That's actually broadcast communication. This is pretty simple. If you have one data, that you want to send to everyone. So maybe you have one array and you want all the computers to compute the same operation about the same array, okay? Or maybe you have one constant that you have to share to everyone in the distributed architecture. So what you just have to do is use this broadcast operation. It will get the data that you have or that you pass to this function and send it to each node in your network. Like each node will receive the same data. Okay, let me show you that in the code. Here is a simple example. We have this data for everyone. It is dictionary, a simple dictionary, and we use this bcast function to send the data to everyone. I'll just show you what each worker is getting at the end. We just have one. If you see it well, this worker is the master with rank 0 is the only one that has this data, and he's sending it to everyone. Okay, so let me show you the results by computing followed by. You will see that 0 will get the same data, 1 will get the same data, and everyone will get the same data. But we actually have this data just for 0. So this bcast is actually broadcasting this data to everyone. So everyone is getting the same data. It can help in the case that I discussed, that I kind of said before, like sending the same data, same constant, or same array to everyone, so they can maybe do a kind of computation on it. The next operation in our list is the gather operation. This can be also really helpful when you want to get a result from different nodes after computation. So as you can see here, each node have a different data, and what you will get at the end is a kind of an array. Maybe it depends on how you get it, containing the result of each node. Let me show you that in the code directly. This is the gathering code. It's pretty simple. What we do here is, for example, we just get each worker just multiplied by 3, for example, and I will show here with this print what the number that each worker have, and you will see the result that we have here from this gather function. So when we call this gather function, each worker will send this data that I'm sending here to this root. This is the worker with rank 0. So, and the worker with rank 0 will receive it, and I will print it here. So let's just execute it so you see the result. As you can see here, the final result is 1, 0 for the worker 0, actually, because the worker 0 have the rank 0. 1 for the worker 1, 8 for the worker 2, 27 for the worker 3, and 64 for the worker 4. So we gather all the data in an array, and we can actually do whatever we want on it on the master node. The last operation I wanted to show you in this video is the reduce operation. It's really interesting because it is actually where you can get this data from the gathering, but instead of just getting a data and putting it in an array or something like that, you can apply function to that, to those data that you're getting. I think if you know the reduce function in programming, in functional programming, it's actually what you're doing here. Okay, it's actually the same principle. We have a built-in function into MPI like sum, mean, max, mean like MEAN, that you can use maybe to just get a sum. Like in this case, we are using a sum. If we call the reduce with the sum operation, each node here will send his data and it will be sum at the master node, and we'll get this 10, like 3, 6, 10. We'll like get 10 here. If we had max, for example, we'll get 4. If we had mean, we'll have 10 divided by 4, that's like 2.5, I think. Yes, and you can also write your own function for this reduce stuff. So let me show you that in the code. Here's an example of the reduce function. Okay, I wrote this function reduce. It's actually the same as if I just wrote like mpi.sum here. Okay, let's execute, and you'll see the result, and we will just tweak it a bit. You will see that we are getting 10 here. It's actually the same result that we had on the slide, because we are just summing the result that we are getting from this reduce function. You can just replace it by mpi.sum. You will see it's actually the same result. Okay, let's execute that. I'm getting also 10 because this sum is, yeah, what I was saying before. But we can do much more things. If we can just maybe type this reduce function again, and maybe say when we receive the things, we just multiply everything. Okay, I don't know what will be the result, but if you know, of course, it will be 0 because we are starting with the node 0 that have, as the node 0 have the worker 0 and we are reducing from everyone, equals and is 0 also. We can do much more things. I don't know, divide or whatever. Some main, if you know how to reduce, actually how to use the reduce function in functional programming, you actually can do whatever you want using the same logic in this reduce function in the context of the MPI context. So that was the last function I wanted to present about collective communication, and I think we just reached the end of this chapter. If you want to know more about MPI, I will just put a lot of resources and links in the blog post. I will just put in the description below. And in the next chapter, we will just discuss about GPU. It will not be too practical because GPU computation is kind of too basic, and I think it is just hard to understand. It's not really Python, and I wanted to do the whole series in Python. So I'll just explain why GPU are really good for computations, and in the upcoming video after the GPU video, we'll talk about more interesting topic like distributed storage and database sharding and much more interesting topics. So don't forget to subscribe for upcoming videos, and see you in the next one. Bye.